This will be a miscellaneous topics. I might add another one of these later, but this will take care of us right now. So I'm going to cover like the miscellaneous topics that aren't necessarily that haven't gone over yet. All right. First thing, let's talk about polarization. All right. Remember that polarized lenses filter light through. So I'm drawing a polarized filter right now. All right. And you have over here, I'm just going to draw in orange, unpolarized light. It's going in all kinds of directions, every which way. There's no organization to it. Whenever the light passes through this filter, though, it's only going to be going in this direction. Any other light beams that come in are going to get blocked. Now, what happens if I take this filter and turn it at 90 degrees? Well, if I have this filter and the light goes through, it's going to be coming through only in this one direction. If I put another filter at 90 degrees, this orange light comes in and it gets stopped. There's no light coming through. So over here, you would see nothing, right? And this concept helps us out with glare. So let's take a look at what happens with glare. If we have a surface, let's say that you're on a pond, okay? Here's a pond down here, and you are standing on the bank. So here's a bank, and you're fishing. So we have you standing on the bank with a fishing pole and a line into the water. Now, the sun's out. It's really bright. It's going to be a green sun just for the heck of it. And the sunlight is coming. It's unpolarized up here, but whenever it hits the water, it hits the surface just like if light hits any surface. If it's a reflective surface, the light that hits the surface and then bounces off is polarized. It's polarized in the same direction as the surface. So in this case, the light would come off horizontally polarized, right? So it would be polarized in such a way that it was moving horizontally, all right? Because it's going to be parallel to the water. So the light's going to be polarized this way. All right? Now, you want to be able to block that with your awesome sunglasses that you have. These are definitely Folkleys. That's okay, though. All right? Now, you want to polarize it. So what if the light is coming off parallel to the water, what direction would your sunglasses need to be? Well, if these are your sunglasses, if this is one of the lenses, if they're like this, if that's the direction of the polarization, and the light is coming off parallel to the water, well, this lens, if you're standing above the water, would also be parallel to the water, right? Because if you draw a line out from the top of them, imagine drawing a line out from the top of them, you would notice that they would be parallel. So your sunglasses would need to be polarized like that in order to block that glare. Because now this light from here, which is parallel to the water, is going to strike those sunglasses and get blocked because it can't go through. So you wouldn't have to worry about the glare. Alright, so that's an important thing. Next, let's talk about flat mirrors and what goes on there. So here we have a flat mirror. A couple of interesting points. I'm just going to draw an arrow because, you know, obviously if you know anything about my drawings, they're horrible. So an arrow I have trouble messing up, but I just did, so it's okay. But what we're going to do is we're going to draw what happens to this arrow when it hits the flat mirror. So the great thing is a flat mirror, whenever that light comes in, remember that the angle of incidence is equal to the angle of reflection. And this is the angle of incidence means the angle that it comes in at. So incidence is just the angle that it hits at. So if this one comes in at 0 degrees, it's going to leave at 0 degrees. All right? Now, we're going to have to draw another line. We're just going to draw a random one, but it doesn't really matter. The point here is that there's a normal to the mirror. We talked about this when we talked about waves, and the angle that's here is the angle of incidence. It has to equal the angle here, which is the angle of reflection. So these two angles should be equal to each other. All right, if this is the case, then what we should see is that these two lines intersect in such a way that the image and the object have the same height. All right, not only that, but if the object was 2 meters away, the image should also be 2 meters away. And the way you can think about this is if you take your hand and put it on a mirror, your hand or your image is now an arm's length away from you times 2, because your arm is in the way of your image and the image's arm is in the way of its image. So you're basically 2 arm's length away from your image. All right, and the same thing would happen anytime you're in a mirror. So a flat mirror will essentially double the distance that you're seeing. Okay. Another brief thing. Please remember that if you have a mirror, if you have light coming in and striking, and then light leaving, there's a normal here, and the angle of incidence is the angle of the light from the normal that the light coming in hits with. So this is the light coming in here, light's coming in here, it hits, and it's got this angle with the normal. Now, the other angle over here is the angle of reflection. Alright, this is the light of the reflecting ray. And these two angles should be equal to each other. Alright, lastly, why is the sky blue and why is the sunset red? Well, the sky is blue, again, because, we've talked about this before, but essentially what you need to know, the sky is blue because of scattering. And what happens is, if the light wave, if the wavelength is smaller than the particle, it will scatter. And so what happens is, blue particles, or blue light, is smaller than the molecules in the atmosphere. So blue light will scatter and appear to be filling up the sky. Now, that answers why the sky is blue. The sky is blue because blue light scatters and causes there to be a appearance of blue light staying in the atmosphere. Alright, so that explains why the sky is blue, but how about why the sun is yellow or why sunsets are red? Well, if the sky is blue, alright, the reason a sunset is red is similar. Alright, now as the sun sets on the horizon, so like let's just draw, this is a field, and your sun is setting over here. Why does that sun appear to be orange? Well, remember that we have these colors, alright, the colors of the rainbow: red, orange, yellow, blue, indigo, and violet. And as it gets towards the horizon, there is more substance for the light's rays to travel through that's coming from the sun. So there's more stuff in between you and the sun's light. There's more stuff here, like clouds and dust and all kinds of stuff. And so as the sun goes down on the horizon, initially just these colors get scattered. And so the light reaching your eyes, I forgot green, didn't I? There we go. So the light reaching your eyes is red, orange, yellow, green. And so that's the reason the sun appears yellow, because red and green combine together to make yellow. So the sun appears yellowish in the daylight sky because the blue and indigo and violet are being knocked out in the upper atmosphere. But as the sun goes lower on the horizon, you get more and more of these rays are getting knocked out because it's having to go through more and more of the Earth's atmosphere. So now we have green getting knocked out, so the sun appears kind of orangey. And then as the sun continues going down, we'll knock out yellow, so the sun now appears a little bit more reddish orange. And then after we go down right on the horizon, we've knocked out orange, and now as the sun is setting, it should look red because we've knocked out all the other colors of the rainbow due to scattering. And so the sun will appear to be red. Now, what helps sunsets look red? Well, the more dust, the more stuff there is in the air, the redder the sunset will be. The more vibrant the sunset, if you have more stuff in the air. So while smoke and pollution are not necessarily good for the environment or for humans, they are prone to make really lovely sunsets. Alright, so these are like the miscellaneous items from light and optics, and I hope this will help you on your test and on your homeworks.